Hey, it's Tim here from My Engineering. Today I'm going to show you why it's critical that when you 3D scan for leak repair, that you clean the pipe prior to scanning. This includes removing all insulation, dirt, and scale before you take your 3D scan. So what I've done is using this valve, I've scanned it in the clean condition, also scanned it with some insulation residue on it, and I'm going to show you how that affects the measurements when we bring it into the computer. So you can see on this valve that there's some fuzz left on here, some insulation residue. Now, when you're measuring by hand using calipers, that might not matter so much, as with the calipers, you can compress that insulation down to the bare pipe and it's going to have a minimal impact on your accuracy. But when you scan and we bring it into the computer, we can't really tell the difference between bare pipe and where there might be a little bit of fuzz left over. So I'm not going to show the scanning, but I am going to show you what this looks like when we bring it into the computer. So here's the valve, the first scan that I took with the pipe being clear. There's some marring on it, but there's no insulation on here. So what I'm going to do is I'm going to fit a cylinder to this. And this is a fairly standard process that we use when we're extracting measurements. So I'm going to click a spot here. And what this is doing is it's finding all of the points that it believes to be a part of this cylinder. So here we go. This is what it looks like. So it's picked all the triangles on here that it believes are part of the cylinder. It's actually ignored a bunch of the marring, which is nice. So what I do is I inspect this to make sure that this is in fact all the data that I want to use when I am taking my measurements. So I think that looks pretty good. So I'm going to fit a cylinder to this. And then once this cylinder is fit, I'm going to check the measurements of it. Okay, so the cylinder's fit here. So if I click on this cylinder, it's going to tell me the dimensions. So I got 30.082 millimeters on radius. So that works out to a diameter of 60.164 millimeters. Okay, that's how that works. If I want to take a look at the accuracy of that cylinder, I can compare the actual cylinder itself that I created to the pipe to see how round the actual pipe is. In this case, it actually looks pretty good. There is some deviations, but that would probably be fine. If it was really out of round, then we would end up taking a cross section and using an oval or a custom profile. But for the purpose of this video, I'm not going to go too deep into that. So now I'm going to do the same process looking at the pipe with the insulation residue. So here's how the scan looks with the insulation residue. So you can see that there's all these gobs of stuff on here. That's how it appears when it's in 3D scan format. So there might actually be some tiny little strings in here that I can't actually see. It just fuses that as a part of the pipe. So what I'm going to do is I'm going to do that same thing where I create a cylinder and we'll check the results. So what I'm going to do is I'll click a spot here and you can see it's pretty intelligent. It actually scrubbed out a whole bunch of this insulation, but it didn't grab the whole pipe. So I'm going to grab another section in there. That looks pretty good to me too. And then I'll go to the other side, select here. That looks pretty good. It's not really picking up any of that fuzz from what I can see. Maybe grab some in there. So the more points that we grab in the spot that we're landing, the more accurate it's going to be because it's going to use all that data to put a best fit cylinder on. So that looks pretty good to me. So I'm going to create a cylinder from that. And it measures 30.296 millimeters radially. So to create a diameter from that, we've got 30.296 times 2. So 60.592. So here's my measurement with the insulation on, and here's my measurement with the insulation off. So the 60.164 would be the bare pipe, and this was the 60.592 is the measurement with the insulation. So let's take a look at the difference of what that is. So if I subtract one from the other, we had a difference in measurements of 0.428 millimeters. So in inches, that is about 17 thou. So the one pipe measured 17 thou bigger than the other. Now, this is a pretty small pipe, so that might not be a huge issue. Although there are some clients that we work with that like to fit their bores really tight using only 20 thou of diametrical clearance. So if that was the case and they left the insulation on, then it probably would fit loose and that would be an issue. So even though when I was constructing the cylinder, I looked pretty closely and was picking points that I thought were good pipe, but there might have just been little traces of insulation left over that caused it to measure big. So I did what I thought was a pretty good job, but again, there might have been some artifacts in there, which I can't really tell by looking at it on the screen, but there might have been some stuff in there. And actually, I guess there was because it measured bigger that ultimately affected the diameter of that pipe. So this is the kind of issue that scales when you get into bigger pipe sizes too. So if you've got a 30-inch pipe and you've got a little bit of residue on there, then it's probably going to grow just that much bigger and it could cause things to fit loose. So it is very important that you clean off the pipe that you're scanning, the object that you're scanning, right to bare metal if possible, before you take your scan so that we actually get accurate measurements and we can design the enclosure to fit properly. So I hope that this helps clarify why it's so important to clean the pipe off when you're using a 3D scanner. 3D scanners do behave differently than calipers and tape measures. When you're using those kind of tools in the field, you can often pick good spots to get your dimensions. But when we're working with a 3D scan, sometimes we can't actually tell what's a really good spot versus a spot that's not so great to extract our measurements, especially when the layer of insulation is really thin, like just a little bit of fuzz on there would be very difficult to tell. I did scan this using a Space Spider scanner, but that doesn't really matter. This is scanner agnostic. So no matter what equipment you're using, you're going to want to make sure that the object is fully cleaned off prior to taking your scan so that you get an enclosure that fits perfect.